Hello, everyone.
Hello.
Welcome. Happy holidays. Either impending holidays, which sounds ominous, or currently occurring holidays. Imaginary and real.
Hello.
Yeah. Unfortunately, there were some weird technical difficulties as I was loading up the stream. My hopefully that won't play out on the stream. My event connection the calendar that I have in this streaming software that connects to YouTube and LinkedIn just disconnected. Like it was just like nah. And
It's
then
on holiday.
I guess it's also on holiday. Probably some like API updates that didn't, roll out or something like that. That's my guess. Very appropriate to the proposed topic for this stream. Yeah. So hello everyone. We got Steven. Sorry if I shortened your name unnecessarily. I assume I can kind of do whatever because you're lawless. And then we've got Andrew. I think maybe you're new. Maybe you're new to the stream. If you're new to the stream, thank you for joining the stream.
Speaking of shortening names, real quick. Is your full name Daniel?
That's classified.
Well, my middle name is Daniel, which is why I feel
fellow
I'm able
Daniel.
to ask you that question. So,
yeah.
It's a good name. And
yes. Yeah. Is Eric short for anything?
No.
I had to ask.
And don't shorten it.
No, I would never. I mean, once you're at 4 letters, you're kind of at the nickname stage.
I suppose.
Yeah, because otherwise you just go to 1 letter. Like there's like going to from 4 to 3 letters. What's that about?
Diminishing returns, kind of.
Exactly. Yeah, exactly. Okay, well, welcome. Thanks for joining the chat. Feel free to chat, folks. Don't be afraid if you're lurking to chime in every once in a while.
Yeah, tonight I think is going to be a bit more freeform and
a little relaxed.
So we want to hear from you and chat about various things that we steer the conversation towards.
Yeah, that'd be awesome. For people who are new or who have short memories, my name is Dan Reynolds. It's short for Daniel Reynolds. I'm currently working at Epic as senior technical audio designer. I've been in games for over 20 years. Long time. Feeling old. And I'm joined by Eric Buchholz. Or so he claims. That's how his name's pronounced.
Yes.
Yeah.
And we can include my middle name if we want to.
Eric Daniel. There's already too many Dans and Daniels. Like I need to weed them out.
It's your turf. You got it.
It's a little Highlander action there. So yeah, and how you've been working in games for a while now, but as a technical designer a little bit shorter.
Yeah, so I mean, I've been I started out doing music, and that goes back into school days, and so it's hard to put like a total number of years I've been working professionally on stuff because it just kind of all blurred together back then. But
or you were like a consummate non-professional music professional.
Sure.
Unprofessional professional.
Yeah, we'll go with that. But no, I've been doing things with Unreal specifically for over 5 years now.
Nice.
And
that's awesome.
It was my pandemic hobby, right?
Oh yeah.
So yeah, it's been good. Really like the technical side of things, and I think that's kind of why I wanted to talk about tonight's topic, which is a pretty big topic. It's not even a topic; it's more of a realm of discussion.
Yeah. Yeah, you could have a whole live stream series on it.
So what are we talking about?
I think so. I think we're talking. Well, so I would. This is actually something that I kind of regretted, like having named the stream, because I would say it's like systemic design.
Oh, did you name the stream? I haven't
I
seen
named
the.
it systems,
Oh, okay. Yeah.
but
I mean, yeah, like I would call it more like if we're going to talk about like building systems and designing tech and architecture, like kind of, I'm not sure what the best term for it is, but we don't have to care about that. We can just dive in.
yeah, I kind of want to actually roll back a little bit,
Okay.
because I think this is something that I see a lot for folks who are interested in getting into technical design. And maybe it could just be, I don't know if I would, maybe it's not technical design as much as it's just like sort of developing software or something like that.
Mm,
Because I feel like one of things that people need to frame coming in or reframe sometimes if they've been doing sort of so-called non-technical work or just um, or just starting out in like implementation.
yeah.
I feel like one of the big reframings is thinking systemically, because and that's actually maybe how I would qualitatively distinguish someone who's implementing versus someone who is who's doing
Mm,
technical design. Because I kind of think of someone implementing as using the existing framework. They're using the existing
yeah.
implementation pathways. They're just sort of exercising them, and uh, I think that a lot of people would, not everyone, but I think a lot of folks would sort of just roll that under under the purview of the sound designer, the audio designer, music designer.
Sure.
Whereas I think with technical design, there's a little bit more of a thinking, like it's not just create. I mean, you can just create new implementation pathways, right? You can just do that.
Yeah. Yeah.
But I think that there's an ask or like to make those pathways sustainable, to make those pathways um, useful beyond the direct implementation, is to start thinking about more generalized use cases. And I think that when you start imagining, okay, well, I've solved the exact problem that I need to solve in this case, and then I need to start thinking about what are ancillary cases? Like, could this also be used in this other scenario? And then I think when you start walking those paths out, what sort of develops is ideally a system
Just to kind of maybe take it even a step further back, like when we say systems, like what are maybe some concrete
what are
examples of what we're
systems.
talking about?
I think that's a really good question,
Because I think some
because
folks might be watching who are interested in tech design or building systems, um, but just not sure at what point something becomes just an implement goes from an implementation to a higher level system.
yeah, I think system. So I'm, uh, I would probably actually abstract system even further. We can go all the way up here, right? Like we
Yeah,
can go
yeah.
all the way up. So, like I feel like a system is a composition of elements or components that work toward some result.
I agree, and I would say that systems are built within frameworks. And if we want to make a distinction between what a system and a framework is, frameworks provide scaffolding
Yeah.
to build um, behavior.
Yeah, I think a single, but a single behavior could be a system. I think you could have a system that has a single application.
Yeah, correct. Yeah.
Um, I think appliances are a great way to think about systems. Like I have a rice cooker, but I haven't been eating a lot of rice, so I don't use it. You could use the rice cooker for other things, but it's very single purpose. Whereas I also have an oven, and the oven is a system for heating things, and it doesn't care about what you put into it.
Hmm.
It will heat them either way, right? So I think but what makes up a system? It's like, okay, this system's purpose is to heat things, so it needs to have some enclosure to so that you have temperature distinction from outside of the system and inside the
Hmm.
system. It needs to have some kind of heating element. And that could be enough, right? And you just have a heating element and some enclosure, and you've got an oven. Is it a great oven? No. Like at some point, you're like, oh, I actually want to heat things at different temperatures. So I need to be able to control or modulate the temperature of the heating element, right?
Hmm.
So now you're starting to add features to the system,
And you might have some sort of infrastructure, like you need electricity, or maybe you want to switch that out for gas.
right?
And so you
Or wood.
have like, yeah,
Yeah.
it's a good
And
metaphor.
yeah, and so and okay, you've got a heating element, you need fuel for the heating element. What is the fuel? How does it work? How do you manage it? Right? All these sorts of questions come up. And so basically you have these inputs, you have a result, and you have elements or features or components to the system that flesh out its capabilities. And I I think the switch is thinking broadly about the application of the thing that you're building. Um, so for example, if you're like, oh, I have this specific issue where I need to get this data from some animation system and feed it over to this other thing so that I can know when this thing's moving and at what angle or something like that. Then you can just do that. You can just pipe the data
Hmm.
from one place to another. But what if they change the animation? What if they change the animation framework? Like, what if they swap out to like a different type of animation system,
Yeah.
right? And so then you need to think about, okay, how are these? What am I going to serve? Is it just this one time usage? Is it every time that we do this one thing? Or is and so you can walk that out into a broader, more general purpose thing. And for your project, whatever your project is, obviously you need to ship the thing. And so you kind of have to put constraints on the applicability of whatever you're building, and make decisions sometimes that prevent you from expanding into other applications.
So the word constraints, um, I think, is probably one of the most important aspects of a system. Like without constraints, there's no real confines to what the system is supposed to be doing. Um, Maybe we can talk about that a little bit later, but I think you need constraints to protect the functionality of your system. Otherwise, you're at risk of overgrowth, or like, the system going beyond the scope of what it should be doing, and just some downsides to that.
Yeah, I think I think the application of the system that you're building cannot be thought of in a vacuum. I think you need to look at the larger ecosystem and see where it sits and what purpose it fulfills in that larger ecosystem, because there's many systems in something like a game engine, right? And so you don't want to necessarily rebuild something that already exists. You don't have to, right? That's sort of a waste of effort, potentially. Um, and uh, and then you may also have, as you said, sort of constraints that are imposed. In other words, there may be constraints that you impose from a design perspective, because it has to fulfill a specific need, even as general purposes may get.
Mm-hmm.
But there may also be other constraints, like the larger framework it has to interact with, or just its operation and usage.
Yeah.
Right. And I think there are other constraints, like time constraints and human resource constraints. You know, the proposition of, say, let's say you have a game engine that's been built up over 30 years. The proposition of replacing all of that is pretty daunting, and it may not be cost effective depending on your production. We got really abstract there.
Yeah, let's bring it in a bit.
I just think that I think what I want to convey starting out is, I believe systemic design, or thinking about systems when you're designing, is a really important part of working inside of software in particular, but um, a I think it elevates the things that you create. I'll give an example of my own sort of path, sort of discovering this, um, and it links up to Soundscape. 0 days since Dan mentioned Soundscape, but I was tasked really early on in my work at Epic with making a demonstration of these partnerships that we had with spatial audio companies. Like Valve had developed a spatial audio plugin for Unreal, and Google had developed one, and uh, Oculus, at the time it was called Oculus, had developed one. And so we had these plugins in our ecosystem. We were shipping them with the engine, but there wasn't like a demonstration of how to use them. And so I was like, okay, I'll do that. I'll make a level for that. And I sort of stole a level from our like mobile texture showcase.
Mm-hmm.
And it was like this temple, and I had I picked it because I thought the geometry might present well, sort of the IR generation from Valve.
Yeah, I know the level you're talking about. Yeah, that's the
Yeah. And so I was like, I want to. There was no sound in the level. That was another sort of feature, is that I would design all the sound.
Mm.
And there were these different things in the level, like there were animated torches, and there were these statues and cool lighting and different rooms. But that was also part of why I picked it, is they had long, narrow hallway. They had a enclosed room and then a partially enclosed room. And I thought, traversing these spaces would present reverb in a really interesting way. And and then it was set in this like it was sort of I felt like it was Greek inspired, but it was set in this sort of coastal landscape. So when you looked out the open uh, area, like a sort of balcony
Yeah.
area, you sort of see this distant ocean. Anyway, so I went. There were trees, and I was like, I need birds, like birds. I want a bird, and so I was like, I'm going to create a bird system. And so I made this blueprint actor that I could just place in the tree, and it had this timing system. It had a big timer and a little timer because I knew that birds didn't just tweet and then wait and tweet, and wait. What they did is they talked, right? Like they sort of like had phrases, and so I got these sort of I captured birds, I recorded birds,
You
and
captured them.
I captured the sound the birds made.
Not the birds themselves, just
No,
the
this is like one of those things of just like it's really good to have a recorder handy. And I used to have a Zoom, but that was really clunky to lug around. Like I had a Zoom,
yeah.
the five, I think. Anyway, it was like a multi-channel, and it was just it was just too big. I got a Roland R07, which was great because it's like smaller than a cell phone. It almost at a distance might fool someone for like a old flip phone or like a
Sure.
BlackBerry or something like that. And so it was really discreet, and it was something that I could just put in my pocket. The Sony's, the Sony's, the classic Sony's, whatever the PCM10 or whatever it's called. I forget what it's called. Those are like impossible to find. In fact, I know a sound designer who's making them impossible to find because he buys them every single time they go on sale. He has tons of them.
Huh.
Anyway, so I had this rolling. Anyway, so it's like, yeah, walking to the bus stop and passing by some bird making noise in the tree, and it's like, oh, this is perfect. No one else is around. Let me just record this bird. Anyway, so I had some bird recordings, different species that I'd sort of accumulated over time,
Mhm.
and I wanted to sort of recreate the sort of phrasing, right? And so I had this big timer which would wait for a phrase, and then I had this little timer that would sort of concatenate words
Like
of a
words
phrase.
versus sentences as your timers, basically.
Something like that. Yeah, exactly. And um, so yeah, I had this system of like big timer, little timer, and uh, randomization and all this sort of stuff. And I was like, great, I got this birds, put them around on my trees. And then I was like, well, okay, I need something for waves. And I went out to the peninsula out here, and recorded some waves breaking on the like pebble beaches and stuff like that,
Mhm.
and some of the rocks and stuff like over in the like Ruby Beach, and it's beautiful. The Olympic Peninsula is gorgeous. Anyway, got some really great recordings, and I brought them in, and I started building a system for waves. And as I was doing that, I was like, this is like very similar to my bird system. Like it's basically my bird system, but with some simpler stuff in it. And I was like, whoa, hold on a second. I'm starting to see something. And then I realized I could just reuse my bird system with different parameters, right? And so then I was like, okay, next I want to tackle fire crackles. And so then I was like, well, I got a system for that now. I'm pretty sure. And as I applied this bird system to all these other sound behaviors, what ended up happening is I ended up creating like a data struct that described a wide variety of sound behaviors. And this is what I realized what I was doing was basically creating a data driven system. And I ended up doing a whole talk about this. I did a whole Unreal Fest talk in 2019 in Prague. The only audio talk that year, and it was about data assets. Because once you've built a system, then what I realized would be useful is having the data separated out and portable, right? Because I just had these I had these actors and they were instanced in the level, and all I needed to do is reuse the actor with different data, and I realized that the actor instance that's in your scene, you can't you can't bring that over to another scene. You got to copy and paste it. It's
Yeah.
really pain in the butt. But with data assets, then you could define it on an asset, have it in just the asset, and then the asset is the portable part. And because the asset contains all the behavior, it just works. So this was my sort of pathway to realizing that the sort of quality output from me would be to generalize the things that I create.
Mm-hmm.
And that's where Soundscape came from. I was like, okay, I've got this data definition for sound behaviors. It fits a wide variety of sound behaviors. And I was like, well, I'll just make like a native system that does this and have my own little data asset type. The first version of Soundscape, which no one has ever seen because it was only used in the UE5 announcement project, Lumen in the Land of Nanite.
Oh, I've seen it.
Yeah. But it had the little timer. So, in other words, it could create phrases. It could concatenate phrases of sound waves. And when I brought that into when I overhauled Soundscape for the Valley of the Ancient project, I realized that meta sounds were so capable of doing that sort of small sound design, that part of the sound design, that it just seemed unnecessary to incorporate that into the Soundscape design. And so Soundscape, as it became publicly available, was designed in the context of meta sounds and their capabilities. So like on this journey I had, and I went through troubles too. Like, for example, in the first version of Soundscape, the audio director had made all these feature requests that to me violated the idea of Soundscape as being like he wanted to handle more like Golden Path type sound events. And I felt like that contradicted the goal of the system. And so when I overhauled it, I removed those features and did that stuff in a different way.
Yeah.
Yeah,
I guess just to kind of dig into your journey a little bit.
Yeah.
So your early versions of Soundscape or your bird system.
Yeah.
Where did your system live? Like how did it?
That's a great question. Yeah.
Because there's a handful of ways you can build systems and like design patterns kind of that I would say are most commonly used. And I think we should touch on a few of them, but I think your early example might be a good one to start with.
Yeah. So basically the bird system only lived in the Spatial Audio Temple. In fact, you can go, if it's still available. I don't know if you can still download it. It's called the Spatial Audio Temple. I think it was called the Sun Temple or something like that, or the original level. And I was like, well, this is going to be it was going to be next, downloadable next to it. So I was like, we're going to call it the Spatial Audio Temple. And Aaron was so down for that. By the way, that working on that project was really fun for me because I had an office with surround sound, and I spent a long time just listening to that that project. I really enjoy designing background ambiences,
It's nice when you
and
can just sit and soak it in, you know.
and especially when it's surround. Like honestly, 3D ambiences and surround is so good.
I want to rephrase my question a little bit.
Yeah, sorry. It
So
lives only in the spatial audio temple. You can still
it
get it.
lives there, but when you're in the project, like, is it just an actor that's in the
Yeah, it's
level?
just an
Is it a
actor.
component on something? Like,
No, nothing that clever. It was just an actor. Just made a blueprint
so you had
actor.
an actor in the world that just was like a
I just
manager.
placed it in the tree.
So okay, let's talk about that
Yeah.
type of system, right?
Yeah.
Would you say that's a good way for people to build systems?
I didn't stay with that design pattern when I fleshed out. I mean, Soundscape doesn't do that. It's completely actorless, actually. So uh, I I th- I think it serves the all those steps broadened the usability, in my opinion,
Yeah.
and simplified to a certain degree some of the implementation process.
Hmm.
So I wouldn't say it's a great design practice, but it's still pretty usable, and I think it still happens a lot. Yeah.
Yeah, I mean, for me at least, it was like I just didn't know of the better ways of like the better ways of having like a design, like a system design. Like
Yeah.
it's the easiest way to get started is to make a blueprint, and the first one is an
Yeah.
actor, and then you could just put it in your level. Then you
Yeah.
have like your logics in the level. That's great. But
Yeah.
actors have, there's a fair amount of overhead when you compare it to something like a component or
Yep.
like a subsystem or something like that.
Yeah.
And oftentimes we don't need like a transform or like a physical embodiment in the world, right?
Yep.
So like having a lot of that stuff is just maybe a bit extra, and it kind of clutters up your blueprint and can be confusing for people who are trying to figure out, if those things matter, I guess.
Yeah. There's sort of a history there. Like UE4 was kind of a transition in terms of actor component movement. Like
Hmm.
UE3 was very actor oriented, and um, if you open up uh, like an early version, like an early sample project from UE4 days, like shooter game from 4.0, it's just ambient actors all over the map, right?
Yeah.
They're just all hand placed ambient actors. Some of them are spatialized, some of them aren't spatialized. And all of the behavior is sort of defined in the sound cues. And this is a very UE3 way of thinking
Mm.
about things. In fact, in UE3, there were four, if I remember, there were at least four different ambient sound actor types. And they had different behaviors. One was just on all the time. One you could turn on and off. One had like a spline that you could move around, that would move around
Hmm.
the audio, um, and or the audio source position. And so I think one was a one shot. I don't remember. There was another one that I forget them, but I feel like there was kind of a transition. You see later on, we're moving away from just placing ambient actors everywhere.
Yeah.
And this was still part of that. Like the spatial audio tempo approach was like, oh, I just need an advanced ambient actor. And so that was kind of my design approach there. UE5 was one of the things that happened in the sort of Fortnite development was um, the expansion of plugins for gameplay. And that's where sort of the game feature plugins, which now are just part of UE5, sort of came from, was this idea like, oh, we've got this, basically a long term live service project that we need to sort of update in little modules all the time. And so um, the UE4 to UE5 transition was moving things into a more modular, extensible
Yeah.
paradigm. And you can sort of see that even with the code itself, like there was so much code was in the engine module, back in the day, and now it's like, no, don't touch that module.
And pretty much every new feature added in UE5 is a plugin.
Yeah, exactly. And that's the other thing is like UE5, like Unreal becomes really big as its own code base, right?
Hmm.
Like we had a really fun. I don't know. I don't think you can find it. I don't know if you can find it anymore, but there was a fun sample project that was Flappy Bird clone. I forget what the original game was
Mm.
called, but it's like the bird
Yeah.
dodging the pipes or whatever. Anyway, that was like a mobile showcase project where they went through and just tore out every unnecessary module so that they could fit it in 25 megabytes. Right?
Yeah.
And so that was like, because back in the day, back when I was your age, when you delivered mobile apps, all your games had to be like under 30 megs.
Right.
So that's a huge problem if your like base package is like 200 megs or something like that, right?
Yeah.
So yeah, and like look at some of these crazy sample projects, like Valve Agents, like 80 gigs to download the project itself. And no one at home wants to know how big Fortnite is. So like that's a huge problem. And
Yeah.
so and other engines were doing that earlier, having more modular builds. So I think that's just, so you see that as like a UE5 paradigm. And I think following along that line, I migrated my work to a plugin. And something else that is just part of a strategy that I had, and I still have to a certain degree, and I recommend, is when you've got to do work, when you've got an assignment, if you can, sneak in something else that you want to learn into it.
Yeah.
So if I've got to create, I was like, okay, I'll create this ambient system, but I also want to improve my coding chops, so I'm going to do it all in C++. So that was like, that was a choice that I made because I wanted to work on my coding skills.
Yeah.
You can't always get away with that, but if you can, do it. Like, the learning. I think learning is one of the best things to sneak into any assignment that you've got.
Yeah.
So
Okay, so you migrated to a plugin.
yeah.
And so what did the structure of that look like?
So there are two reasons that I did a plugin. Actually, I want to talk about that a little bit too.
Sure.
Aside from the fact that there was sort of a paradigm shift, but the other reason was I was working with the special projects team. The special projects team, as it was, back then, was basically responsible for these sort of like cutting edge showcase demonstrations of Unreal, and the like I cannot express the absolute insanity of an ambition of these demonstrations. Like people, let me put it this way. I remember at Project Chaos when we announced the Chaos native Chaos engine, the physics engine for Unreal. We had this live stage demonstration. It was chaotic development because the project was sort of Robo Recall based, and it was based on the Robo Recall project, which itself was based on another demonstration project, and then another one, like all the way down. It was like 4 projects that this project had been reused on, and sort of derived from, and so it was kind of messy, and I was worried that they wanted to have it as a sample project, but I was against it, and many other people were against it. There was sort of like a debate about whether or not it should be a sample project because the amount of work it would have to like clean it up, you know.
Yeah.
But one of the biggest arguments that the pro sample project people had was they wanted people to know that they'd done the demo live. Like the amount of ambition that goes into like the things that they do live on stage are things no one would reasonably do live on stage because it's a massive flex, right? And so there's a lot of stress and chaos, pun inevitable, like I don't know, behind this, and so from my perspective, I realized what was happening was I was starting from scratch every single time I was running into these
Yeah.
situations. And so I was like, I need to start building my own tools and systems because I'm putting work into this thing is kind of getting thrown away after the demo's done. And so that was the other reasoning behind it. So the initial idea of having a Soundscape plugin wasn't even for anyone but me to use it. I was just like, this is going to be my plugin. I'm going to, instead of starting from scratch every time, I'm going to build on it. And the Valley of the Ancient project was always intended to be a sample project for sure. That was basically its purpose. And there was kind of a opportunity to release some audio gameplay systems to the public when it was kind of hard for us to do that and get dev behind it for a couple reasons. One was we had a very small and very pressured audio gameplay programming team, like just barely a team. It was like maybe 2 or 3 people, and they were 100% on supporting live service projects. So they were worried about putting anything out there that they would have to then support licensees and all that sort of stuff. But in a sample project, at the sample project scope, it kind of made sense. It was like, yeah, okay, we could ship it, and it's like there's no expectation that we would be supporting this. It's not like it's not like an official thing. So so I was like, okay, this is cool. I'll add it in. And in fact, on that project, I ended up writing 3 systems. And we shipped 4 audio gameplay systems total. And one of them I didn't even get to use. I built it in anticipation of the need, and then they cut that feature. That happens, by the way, all the time. I'll spend time building a system.
Yeah.
Like for the Valley of the Ancient project, I built a whole interactive music system that never got used.
But if it's a plugin, then there's at least a chance that you can bring that with you to some other project. And I think that's one of the biggest benefits by far of having a plugin.
Yeah. Yes. It's the portability of the system itself.
Now, do you know, can you tell us what the 3 other ones were that?
Yeah. So the 3 other ones were one was a state-based mixing system I called Crossfader. And half of it was naming these. That's half the fun. Another was a chaos fracture collision system. So in other words, it would allow you to define audio events with geometry fracture collisions, and it also did spatial clustering.
So what's that one called?
It's called Uproar.
Dan's really good at coming up with names, by the way, so that's why I'm always, what'd you name it?
because uproar is the sound of chaos.
Ah, yeah.
Um, if you look under chaos in the thesaurus. By the way, I'm good at naming things because I like etymology, and I just go to an etymological dictionary or a thesaurus, and I just look at the word I'm trying to convey, and
Yeah.
then try to find something that. So part of it is just me searching around for stuff, but it's fun. That's part of that's anyway. And then the other one was a music system that I had my designs on for a real long time, but I got sick and I couldn't make it, and so Aaron convinced another programmer to work on it called Underscore.
Mm.
And its design was only partially adherent to what I wanted. And I've resented it ever since.
Well,
I've always wanted to make an underscore that replaces it.
yeah. It's kind of like a mini tangent off of that. So like some of these systems are plugins. They're portable, but at the same time, like it sounds like they have dependencies on these other features, right? And so
Yeah.
if you want to move that plugin to another project, it needs to be using Chaos or
Yeah, I mean, sort of the chaos one is solving a particular complicated problem, right? Because the chaos geometry fractures um, report their data through a listener because they are themselves just a single mesh actor. They're not like the individual collisions are not
sure.
And the way that chaos works, or at least I don't know if it's honestly, I'm not sure how it works anymore because they kept changing it. But the way that it worked back then was that it would aggregate the collision simulation to these sort of solutions, which were basically their own contexts for collisions.
Mm.
And that's how you would get like interactions between multiple actors, fractures. So like if you had two pillars, right, there might be two different actors, but you want their little bits to like collide with each other. And so they need to be part of the sort of same chaos context.
Sure.
But that's really expensive and it grows. And so the original version of chaos, like the Project Chaos version of chaos, I had to have a listener for each fracture solution, each context have its own listener. And so that didn't give me a lot of like, I had to do all sorts of, if you look at that project, I just sort of like assume everything's concrete because it's in a city.
Yeah.
And there's like one part of that project where like the robot busts through a window and I have literal glass break, just I call a glass break sound for it. But there was some glass in other parts of it, and those had to have different contexts in order for me to sonify them differently, just distinguish them. They didn't have like at the time there was no way to query the material and they weren't conveying physical materials either.
Right.
And I had some really crazy conversations with some because they hired a whole bunch of really smart physics programmers who'd worked at ILM and all these sort of and built features for like offline rendering systems. And so for a bunch of them, real-time rendering was a little bit new for them. And I had some crazy conversations about like, the simulation data and the fact that we are like audio is not working on a model, like audio is still kind of working. When you have when you play a sound file, it's like putting a texture somewhere. And so the fact that we still work primarily in sound recordings is due to the fact that we don't have a sophisticated audio model.
Right.
And so you can't just say, "Oh, here's the simulation data. Here's like an impulse into your into this metal, and then we generate sound from that, right? And so I was like trying to describe to this physics programmer like a cylinder being like a really serious problem for audio designers because it can like it can like roll on its axis, it can like slide on its ends, it can slide on its axis, it can like twirl on its rim, and it's all of those sound different from each other, you know?
Hmm.
And so it's like a really complicated problem to solve and try to take this physics data and like interpret it
Yeah.
into different kinds of sounds. So so that's part of the challenge of building audio systems is interacting with systems that aren't designed to interact with the kind of systems that we're building or the systems that we have at our fingertips. And so, yeah, I made a system specifically for chaos because that's a problem that's not easily solved without putting a lot of work into it. And
Right.
so, from my perspective, I was just trying to come up with a simplified implementation pathway that didn't rely on a programmer every time you wanted to do this work.
Yeah.
Yeah. Yeah. Justice for soundscape pigments. Yeah, there you go. Steven watched my talk on building soundscapes. Yeah. But you know, the project we had chaos is able to do a recording of a simulation
Hmm.
and then abstract the output into a animation. And so the originally the when you destroyed the barrier barriers with the light dart, those were originally dynamic reactions. They ended up baking in and then just animating it back. Same with the golem when the golem emerges from the rocks. Originally, that was all simulated, and then they baked that in,
Hmm.
uh, and then they like sort of punched it up with VFX work. Originally I had those simulated, and I had a system to to work with the dynamic interactions, but we didn't use it. We didn't ship with that, and we shipped it out, so you can find it. You
Oh.
can download it. You have to go back in time though, because I think Mark Audie removed it. He's
Oh.
like, "You're not using this," and I was like, "Yes, we are not."
Okay, so plugins are good.
Yeah,
So
for portability.
for portability, but as far as like the actual implementation of the system, uh, I assume it's not actor based anymore, and
Soundscape?
the management at that point, right? If we keep going down the timeline, you went from actor based
Yeah.
manager into what I assume would be a subsystem, right, in your plugin.
Yeah, so I had, in 2018, I fell in love with data assets. In 2019, I fell in love with subsystems. So, yeah,
What are they?
subsystems are really cool. So subsystems are basically, hanger-ons, hangers-on. They're systems that are managed by a higher level system's lifetime. So, like for example, uh, you have an engine subsystem. The engine subsystem's lifetime is managed by the lifetime of the engine itself, of the engine system, I guess
Hmm.
you could call it. The There's a world subsystem, and that's managed by the lifetime of the world um, that it sort of belongs to or spawns under or is created instantiated under. There's a game instance subsystem, and that's its lifetime is different from worlds, and it's different from engine. It's very similar to engine, but it's different from engine.
Yeah.
So there's just different subsystems, and there's more.
Editor subsystem.
There's an editor subsystem, which is so
specific
that
features will have their own subsystems as well.
yeah, exactly. And part of object-oriented programming is inheritance and children classes. So, um, so the idea is to take a parent class and then create your own class
to create a child subsystem of one of those types that we just described.
Yeah, it'll be because it's of that type. Its lifetime is managed in the same way.
So can we do this in Blueprint?
Can
we make a subsystem?
Depends on who you ask. There is not, as far as I understand, a official way to make a subsystem.
I'm pretty sure you can't. I'm just feeling discussion here, but like for people who haven't made a subsystem or haven't dived into C++, like subsystems sound very like low level engine stuff, but they're probably the easiest thing to get started with as far as writing a C++ class, because you make the class and it just exists from when you start the editor or the engine, whatever your subsystem parent class is. But what you can do with it once you have it is you can access your subsystem and the Blueprint callable functions that are on it.
Really cool.
From any Blueprint that you want to access it from. So it's like it's a singleton, right? So there's one instance.
Well, it's not a singleton. Subsystems aren't by default singletons.
Sure.
Only if their lifetime parent or whatever, the parent that they're spawned under, whatever that class is singleton, then that is the case. But like, for example, there's a player subsystem, which spawns for every player. And there's a world subsystem, which spawns with every world. You get multiple worlds at once. So it is. So what's nice about them is they're very good interface or manager class, because they're accessible everywhere, which is really great. Really great.
And so for someone out there who wants to make their first subsystem, like which class of subsystem?
I would recommend a world subsystem.
Really?
Yes. And the reason I would recommend a world subsystem is that, for audio, if they're audio. The reason I recommend a world subsystem is because there is the audio engine spawns this class called an audio device. It's not an actual hardware device. It's just the sort of instantiation of the audio system itself. Like the audio, and this audio device can service many worlds. And so because of reasons, the handle to the audio device is the world. So so the easiest way to access the correct audio device is if you have the world that you need to work with. So I would say a world subsystem for audio folks is the easiest to start with.
Yeah, I can get behind that.
Yeah, and so that because your world is always valid, because the world subsystem is managed by the lifetime of its world. So you'll never have an invalid world where you shouldn't. Something's gone wrong if you have an invalid world.
So how about the game instance subsystem, which outlives the world, right? So you can...
Yeah, that gets a little bit more complicated.
So what instances would you have where the world is invalid for a game instance subsystem?
So one of the things in Unreal, when you're working in the editor, the editor has its own world. The Pi session has its own world. And you have a different world for every client if you're calling a multi-client Pi session. So there can be many worlds. Like this, if you do like a server multi-client Pi session, the server has a world, right? So there's worlds for all these things, and you can also have worlds for sublevels.
Oh, jeez.
So,
Seems...
so this is a challenge to weed through all these worlds. And then the other thing that I have observed sometimes is that sometimes you'll see like a world instantiated like the CDO,
Oh, sure, yeah.
but it's not. You don't want to use that.
No.
So usually when you're working in a game instance subsystem, you kind of need to wait until the dust settles on the loading process. If you look at we've mentioned this before, the great and terrible int main to begin play, like a lot happens, and you can see when game instances get loaded. They get loaded before worlds exist, before actors exist, all this sort of stuff. And so one of the best ways is to wait until the dust settles on the loading process and then call to the G engine, which is a global reference, basically, a global pointer. And then get the persistent world. That's usually the best way. But that's I've had some challenges with dealing with game instances in complex projects, and making sure that I'm addressing the correct audio engine, or audio device. That's
Okay.
So I would just sort of like caution, the game. It's a little finicky.
The benefit, though, of the game instance is if you want to have sounds that persist across level transitions.
Correct. Yeah.
So if that's something people want to do, then that's
Yeah,
why you would deal with that.
Yeah, we've talked about it before, but what happens when you change a level, it calls a memory flush, and as a preventative measure, the audio engine will also call stop on all sounds, regardless of whether you wanted it to or not.
So you don't have any loops that are stuck playing.
You don't
exactly, have an audio component to stop it anymore.
Yeah, well, you can play a loop without an audio component.
Sure.
And then you've got a forever sound. So so all those sounds get stopped. It's just sort of a safety measure, unless you tell it not to. So when you spawn an audio component, like if you call one of the game play statics functions, like spawn attached or something like that, there's a bool that's like prevent from destruction from flush or something. I forget, level change, or I forget exactly what it's called. So that you have to tick that on. But there's another catch, and that is, if the audio component at any time, if the audio component, even if that thing is ticked on, if the audio component is destroyed, then the sound will be stopped as a safety measure. That's not level transition. That's just the audio component getting destroyed. Now, if the audio component is attached to an actor that's attached to a scene or world that is being flushed, then it gets destroyed. And so you need to have something that has a lifetime beyond the level flush, during level flush, that can hang on to a reference, a pointer, a strong pointer to that audio component that basically tells the garbage collector, whoa, don't delete this. I'm still using it.
Yeah.
And so those two things need to be done in order to have your audio component and your sound survive the level transition. And game instances, game modes, there's a bunch of stuff that survives level transition, a bunch of objects, and so those objects are handy. Now there isn't like a game mode subsystem, but there is a game instance subsystem, and so that becomes one of the go-tos
Yeah.
for music systems where you need to have music persist across the level transition.
Loading music or like
Yeah, you just want to like have yeah, it could be loading music. It could just be you just have a continuous soundtrack, right?
yeah.
Something as simple as that. Though
Yeah.
we do that in Lyra, Project Lyra. We didn't use a subsystem, but we did use the game instance, and you can actually see the music manager or whatever it's
Mm.
called is sort of housed in the game instance, and
Well,
the music persists through the from the. In fact, the music system itself just has a menu state or like a in-game state. So
mm. So there's one other subsystem that we haven't mentioned yet that would probably interest audio folks, and that is the audio subsystem class. Do you want to talk
audio
about that?
engine subsystem.
Audio,
Yeah,
yeah.
yeah.
I haven't written one before, but it gets you a lot closer to it's on the audio thread, right? So,
Yeah, the audio engine subsystem's a little bit more advanced. I myself haven't written one
hmm.
because I haven't needed it actually. But what the audio engine subsystem allows you to do is it allows you access to the active sound.
Because it's not running on game thread, right? And so that's kind of
Uh, I don't know.
I'm
It might
pretty
be
sure it's
both.
on the audio logic thread.
It might be both. I don't know.
Okay, yeah.
This is one of those things that I'm not as comfortable with thread hopping,
Yeah, yeah.
you know,
No, it
thread
is.
surfing.
It is a little bit like daunting. Yeah,
Yeah.
for where I'm at in my C++ journey, it's like, oh,
Yeah.
now we have to like make, uh, proxy objects so we can hand things from the game thread to a background
Yeah.
thread or
And
whatever.
you gotta do things like pause the thread while you're copying data over. All this sort of stuff gets a little bit finicky. And because I haven't needed to, I've sort of like kicked that can down the road.
Yeah, I do want
Uh,
to get to it someday, but
yeah. One of the things that is also confusing about thread jumping is when you're looking at an existing framework and trying to understand where the save function calls
yeah,
are and which data is accessible when and all that sort of stuff. For example, like I was recently traversing the play the like boundary between the gameplay game thread and the audio
hmm,
thread where you transition into an active sound,
yeah,
starting with like play sound. And the one of the other things, another tricky part, by the way, I should just mention, another tricky part about working in the audio thread between the game thread is that the audio thread does not exist in editor.
hmm,
So the audio thread is disabled in editor, and all the audio thread calls are actually called on the game thread. And so this is great for editing because that means that you can do crazy things, like you can edit sound cues while they're playing, right? And they'll update, which is insane.
you can't do
Um,
that in a cooked build, right? Because you can't open the
you
sound
can't
queue
do
and
that in
start
the
doing
cook
stuff.
build. It's not safe to do in a cook build. Like it's all this
Hmm.
it's very problematic to do. Um, and so there's lots of benefits to removing the audio thread in the editor,
Yeah.
but the audio thread is a optimization, right? It allows you to do a bunch of processing parallel to the game thread. And so yeah, so just some cautions. If you're like very comfortable with that space, you'll probably do fine.
Check it out.
Yeah, it's going to give you, the audio engine subsystem is going to give you a deeper access. If you want a good example, check out the audio gameplay volume
Yeah.
source code, because that basically operates under an audio engine subsystem. And so that's a great way to like see that stuff.
Okay, let's we've talked about subsystems.
Mm-hmm.
Let's bring it back to maybe folks who aren't ready to open up a solution and start coding. What options in Blueprint do we have for, like, besides actor managers? What would be like the next best thing to a
Besides actor
subsystem?
managers,
Like, what's the next best thing in your opinion than subsystems that you can do in Blueprint?
well, I think that so one thing to appreciate about actors is they're sort of they have like a first class replication system. So if you're dealing with a multiplayer in a multiplayer scenario, it's really easy to replicate data and function calls via an actor. And so there is some value. I've definitely been in a situation, multiple situations where directors, it's always directors, um, where they're like, I want these audio events to be synchronized across clients. And so if you're new to multiplayer game design,
That's a whole
audio,
other night
yeah,
of topic.
audio is generally rendered on the client, and most of the decisions that dictate the rendering is made on the client as well. And it makes a lot of sense because a lot of things are dependent upon the particular state or contexts the player is in that sort of influence, which sounds are rendering and all this sort of stuff. So that's one of those situations where actors are kind of very handy because they um, are sort of designed to replicate data very easily, and so they can be a nice way to uh, build as a manager. You said no, besides actor managers. I mean, that's basically there is a good reason for actor managers.
Sure.
Yeah. Yeah, so that is one of the reasons. That kind of stuff is a little bit, it's not impossible. If you're already writing code, maybe that's fine. Maybe it's no big deal. But yeah, the replication is something to think about in terms of.
See, I tend to shy away from actors for partially that reason, because it adds complexity that is often
Yeah.
unnecessary. Um, if you're replicating events and state across clients through the server, um, you can end up with some weird things happening, bugs, latency. Um, and so I typically, when I'm doing Blueprint and I'm not coding and I want to make like a manager or like a system, I tend to go for like a component, and I tend to put that
Hmm.
component on the game state. Um, the game
Oh,
state
interesting. Yeah.
The game state is like a subsystem. The game state is pretty easy to access from anywhere that has
Yeah.
access, like that's part of the world. It's a little trickier if you have like just a plain object class. You have to
Yeah.
have a world context for it. Um, but yeah, if you can
Uh,
add a game state component to
I
your
think the game state is an actor.
yes,
Yeah.
yes.
Yeah.
So it's
So it should
it
have a world, right? It should have a valid world.
yeah, it will have a world, and it also
Oh, you mean in terms of like making a system with U object? Yeah, yeah. I see what you're saying. Yeah,
yeah, so like U objects, I like to use U objects when I don't need something that manifests in the world. It's just
yeah.
a container of state or behavior. Um, but like
Yeah.
the manager
Less
that
so,
I
yeah, lightweight thing.
yes,
Yeah.
it doesn't mean that you can't have replicated state either. It just means that you have to it has to come from the game state, or from referenced actors that you have access to, or
Yeah. The game state is an actor, so
yes, yeah.
it has all the benefits of an actor. I mean, it's an actor.
Mm-hmm.
It's an A
But the nice,
info actor, which is a little bit different.
mm-hmm.
But yeah, so I would put A info derived actors as a potential manager class as
Mm-hmm.
well.
The other nice thing though is that since it's a component class, it doesn't have all of the extra baggage that comes with the actor class. So if you look at your list of functions you can override, it's not going to be like
Right.
super crazy with things that don't even matter to your system.
Yeah.
There's still some things in the component class that I think is there and that you're probably never going to use, but um, yeah.
Yeah. So that you talked originally. You mentioned singletons, singularities,
Singularities, yeah.
singularities,
Uh,
singletons. I think one of the nice things about subsystems is it enforces a clear population or instantiation of subsystem to its sort of lifetime manager. And uh, components can, are very easily added to as many actors as you want, for better or worse. So that's something to think about in terms of system design and scope of that system.
and maybe we don't get into decoupling tonight, but having components that your actor doesn't need to know about, like the component that the actor can have a component on it without any knowledge that the component is there doing stuff, but the component can latch on like a parasite and like receive those events and like receive the state from it, and
Yeah.
the actor is none the wiser for it. And so that means you can have it in a plugin, apply it to actors. You can disable your plugin, and like your game is still going to work. It's not going to be like, hey, where's my parasite?
Yeah.
So
Where's my parasite?
yeah,
That's
that's
a
my
pretty
metaphor.
that's a that's a really funny framing of the component actor relationship. Yeah, you can attach components to actors on the fly. And yeah, that's very useful. Uh,
I do think it's very
yeah,
important though that the actor doesn't know about it though, because that's when you run into coupling. And here we go.
the
We're not doing it. Not tonight.
codependencies.
Yeah, I mean, there's a lot of benefits to keeping things not crossing the line from referencing your component inside of the actor. But
Yeah, yeah, I understand that.
yeah.
Yeah, I I I mean, if your system is uh, dynamically attached to actors, then you obviously don't want any dependencies in the actor itself on the
Mhm.
component's existence. Agreed. Well, I think that's a good idea. I think there is a sort of uh, component focused design pattern there as well,
Mhm.
because components can be attached to many actors, um, different types of actors. So
So
your system could potentially be portable across, many different areas
mhm.
of the design scope.
And so one thing I like to do with like the game state component and like components that I put on actors
Mhm.
is make like a base component, not for the game state. So like let's say we have two component classes, one for the game state, and that's like the manager that's doing the important stuff. Then a separate component, it's like a base class that a base component class that you add to actors, and that kind of phones home to the game state manager. So like on your begin play of your component, you can get the game state, get the
Yeah,
component that you and register with it. Like you can
yeah,
tell your game state component, hey, like I'm here, like I'm ready to start sending you data that you need for doing whatever work you're doing on the system. And then you can create child classes of your actor component to gather different data depending on the type of actor it is, or and that can all just get sent up to the brain.
Yeah. Yeah, I think what's nice is also, you can look for components on actors. In other words, you could have, an interface that, interacts with actors,
Mm.
and then, third actors, whatever, secondary actors, I don't know, tertiary actors, uh, and then queries whether or not it has a specific component, and then you can talk directly to it, through an interface.
Yeah.
That's where I think like really interesting, like, um, weapon designs, or it's like I fire the thing and, there's a hit, and then you have like a, do you have the implement hit interface or
Yeah, yeah.
whatever, and I think there's, you can dictate behaviors in ways where it's like component to component, across actors.
Hmm.
Uh, what would you say is the purview of a manager? Like, what is the responsibility of a manager?
So I guess it depends. If you imagine that you have your game state component, your manager, and it's just kind of, it doesn't have like a transform because it's on a info actor, right? So it doesn't really, it has access to the world, and so you can query the world, but I use my actor components as like sensors or
Mhm.
data providers, whatever form that may be. Like maybe I need to know uh, just how many actors are in the area, or
Yeah.
when certain things happen on actors in particular. And that could be like a music system, could be a good example, where you have, if there are so many enemies in the area, then we start playing music, and that the manager
Right.
would be keeping track of how many components have phoned home to it, for example. Um, and then you can drive behavior based on the threat level. Like if they're attacking
Right.
you, you can do stuff, or you can do all that through like an event routing system, or just event dispatchers or something.
Right.
Um, However you need to get that data.
Lifetime management, state management,
Mm-hmm.
data aggregation, data interpretation or analysis or
Yeah.
transformation. Um, this is, I think, this goes back to that conversation we had, a couple streams ago where we were talking about music system design, I feel.
I
And I
missed that one.
remember, oh, you missed that one? Yeah, that was a good one. Uh, no, but I had brought up a sort of diagram
Mm.
of these different things, uh, basically, what we're describing here, where it's like I had a manager that's managing the lifetime
Hmm.
of these objects, which have different functions. Like one is to receive and transform data and pass that into, um, the like sound, uh, or to, interpret, state, and pass that into sound, which could just be classified under transformation.
Sure.
Um, and the actual sound instances lifetime as well, um, and managing, events to that sort of dictate whether or not, sort of dictate, play state or instant state or something like that.
Mm.
And there's some abstract ideas like the data aggregation, how does that work? How do you address it? How do you connect it to gameplay systems? It's all sort of questions that have to be answered. How does the data communicate to the sort of sound instance? In the, our case, we have, this sort of render boundary where we have to go through an interface to feed data into our meta sound or sound cue or something like that. And then we have uh, sort of events and other states that might need to be managed. Where does that happen? Does it happen in that sort of data aggregator? Yeah. So, yeah, I think that there's, and I remember when I was working on an interactive music system that was more general purpose oriented. I had to have these components that were part of other systems, like systems I didn't want to recreate, that allowed me to feed data back into um, the uh, the sort of uh, owner class
Mm-hmm.
because I wanted callback data. Like
Yeah, yeah.
I needed the system to be informed, like what bar and beat are we on? What, all this sort of stuff.
Mm-hmm.
Do
Yeah.
we have like a transition boundary coming up? That sort of things need to be communicated back to. In fact, actually, one of the things that I resolved, unfortunately, I think, was I needed to track playback timing in parallel to the render because there were gameplay calls that had to happen in advance, and it
Yeah.
was easier to track playback timing and then be proactive from the game thread than to wait for a callback to
Sure.
instantiate an event because everything was sort of data driven anyway. And uh, so yeah, I think components become the sort of framework has to be a little bit flexible because there'll be components that are responsible for other things. Like, we've got an audio component playing a meta sound. We've got maybe a music clock component that's feeding back music timing data. We've got an output watch subsystem that's being utilized to feed data that is non MIDI clock
Mm-hmm.
based back into the subsystem or the owner or whatever. And so yeah, it can get very web like when you have these greater dependencies. And so I think it's even more important to have clarity on the role every
Mm-hmm.
piece of your system plays.
Like what knows about what, right?
Yeah, and how does it get that information? How does it send its information? And um, yeah, exactly.
Because again, like you want to keep your system modular and
Or just I mean, maybe, yeah, it could just be as simple as like making sure you're writing code in the right place. Like,
yeah, yeah.
sometimes it's like you just need to say, well, this actor or this component is responsible for this thing and nothing else because
Mm.
uh, other things handle this or this needs to be handled another way. Then that would work from this wherever this component is housed. We have where are we reading the chat right now? Oh,
Yes,
just
I
bring it in.
see.
I have built a system with five actors, managers for sound, one for the quartz clock, other important stuff, gameplay input, one for music, and they communicate with an interface. And then it's better to build parent-child relationships with actors components. I think that's what I think that was the. I think that's where Eric was sort of airing toward, was building from a component perspective.
Yeah, for to build parent-child relationship or with like they're not mutually exclusive, right? So like if you have components that all belong to like the same, fulfill the same role, but have different ways they need to go about doing that, that it might be because you have different actors. Like maybe you need to keep track of all of your friendly NPCs, and then you need to keep track of all your enemy NPCs, and they have different data that you want to try and receive. You would want separate components, maybe for each of those
Maybe.
classes, um, or you could probably interface that somehow and just have a single component do it. Um, but yeah, it's kind of just up to maybe like your requirements or your dependencies. I don't know. It's hard to give general advice without more
Yeah,
info.
I think there is something to like like some of this stuff, which is gameplay input, uh, and quartz clock, right, which is like a pre-existing component that has its own
Mm,
function. I think there is a sort of uh, lean into the ecosystem kind of thing that needs to sort of keep in mind. Like it's a pitfall to fight the uh, the design patterns that surround you.
yeah,
You
for
know,
sure.
so in other words, your work, like all the work you're doing is in context of something else, whether it's an engine, you know, like you're working in Unity or Unreal, you're going to do things differently in those places,
Hmm.
right? And that's not just because of the architecture, but it's also because there is a sort of design paradigm that is prevalent in those spaces. You may even have specific design paradigms that are project specific. You may be working on a game project that's designed its own system,
Yeah.
or how it handles these kinds of things. And so uh, it's it's really good to sort of take a kind of inventory of what's around you, and then to lean into those, kind of like the rushing water. It's easier if you sort of let it flow around you rather than trying to fight against it.
Hmm.
So, I mean, it can be very frustrating at times, right? Like the you look at Unreal's code as an example, right? It's like 25 years old, plus years old. You've got, or maybe 30 years old now. You've got, Fortnite is like, I think it's got like a 15-year-old code base. Like there's lots of stuff in there.
Yeah.
And I sometimes see these newer programmers come in and they get very frustrated because they realize that they can't, like, revolutionize everything overnight. They have to kind of play ball, because there's a game that's already in progress. And so yeah, you can't just like walk in onto the baseball field during a game and then throw the football around, right? Like it's just you're gonna get mad because no one's gonna want you to do what you're doing, and then they'll get mad that you're doing it. So
Hmm.
so yeah, there's a little bit of that. You gotta sort of, if you're making like a plugin for the marketplace, then you need to think about the target engine or platform that you're trying to cater toward.
And the systems that are available to you that you
Yeah,
want
exactly. Yeah,
to extend. Um,
exactly. So I think there is a little bit of use your sensible, sensibilities, when approaching a particular design pattern. So we've got like I think some of the early, didn't we just like recently release like a very early access version of Scene Graph?
Maybe.
I think there's some docs on it, and it's just like there's a different paradigm, and so it's like there's something new, and it has different purpose, and it's another great example of how, okay, well, we're gonna have to rethink how we handle some of these situations.
So
And
when you're thinking about, you're making a system and you're thinking about extensibility,
yeah.
and you want to design your system with extensibility in mind, what kinds of things are you considering?
Well, we were talking about the Uproar plugin, right?
Yeah. Oh, is it December 25th now?
I forgot that I had the hat set aside,
uh,
and I was gonna have it
over
on the
the
whole time.
headphones.
I know, right? Um, the Uproar, because you mentioned the dependency on Chaos. I would say Uproar was meant to be an extension to Chaos, and in that way, it was taking the interface that Chaos provided and extending the features.
Yeah.
In my case, I added a component. I had a subsystem, a world subsystem. In that case, I had components that would register the listeners. So
Mhm.
the basically you'd add them, you add the component, and then I had assets, which were just data assets that allowed you to define the clustering and intensity mapping for collision events and braking events. And you would put those on the component, so you could have different mappings
Mhm.
based on the actor you were applying it to, and and then they'd register with the subsystem, and the subsystem would subscribe to the chaos listener. So it would look for the chaos collision component on that actor. So it would look for another child component and register with those listeners, and then it would uh, cluster events. And I used a spatial hash for the clustering system, and I had events with time cooldown times. So there were rules about, like, basically we eject events that happened during the, like, so if it was basically a collision system in that sense.
Mhm. So
Yeah,
uh,
sorry.
as an extension to chaos, like
Yeah.
what features or like what parts of it were extensible that you saw that were like I can build off of that, or
Yeah.
this is where I can fit in with it.
It was their component and their listening delegate.
Hmm.
So very basic. It wasn't great. It was okay. Um, but I think that for that one, did they update? Was there a way to look for the material? I think their solution was just to have the listeners for different actors.
Hmm.
I think they did. I don't remember. I think they did context aggregation separately.
Hmm.
Yeah, like you would subscribe to a solution. I think they called them chaos solutions. So so the listener was moved to the component, um, instead of the solution, which was their original chaos project issue that I had. So that was a little bit easier. One of the challenges that I ran into was um, magnitude of object, which didn't end up being a problem because we didn't end up using it. But uh, when you're trying to cluster events, they had like a gym when we were working on the project where it was like, here's a boulder the size of a small hill, and it was like,
Yeah.
like, and I was trying to design these like really big sounding
Yeah.
cracks and stuff like that. And the challenge for me was like aggregating the data across, such a large amount of space.
Mm-hmm.
Um, whereas, I would also need the same system to work on, oh, there's a
Yeah.
bunch of pebbles falling down a little hill or something. So that
Like.
was, yeah, it was hard to sort of, again, there wasn't a lot of, it was very simulation oriented.
Mm.
And so you just get these like, here's a giant impulse, and then you try to like see if you can collect, does the actor have mass, and
Yeah, have fun
And all
figuring.
that stuff, the challenge, there is that there's all this sort of simulation data that goes into the simulation, but it's all being messed around with by gameplay designers. And they're like, well, if I change gravity, it looks cooler. So, but something the physics doesn't, map
Yeah, yeah.
correctly. And yeah.
So to flip the question, or like to flip your role in the development, then like let's talk about soundscape. Let's say that so I haven't looked at soundscape in quite a while, but let's just say I want to extend soundscape so that
Yeah.
I could have maybe my own custom color that does like
Some other kind of thing.
or
Yeah.
plays like some other type of asset, like custom sound.
Yeah. So you could subclass color. I didn't final it. But it would come along with all the existing baggage.
Hmm.
So, and there's no interface to tap into. So I was not really, that's actually one of the things that I would love to overhaul about Soundscape, to be honest with you,
So
is
what?
that it's not extensible. And I'll tell you, there are two big asks that I get asked for all the time with Soundscape. One of them is teams asking if they can have Soundscape for Wise. And so, and I've actually had, like, I remember sitting down with a licensee audio team and being like, walking through how where in the code they would swap out an audio component for an AK component, and then tell them without, because here's the thing about plugins in Unreal is, by the way, this is not by design, it's just by happenstance, and no one has changed its behavior. They sort of are fine with it. And that is, if you have a plugin in the engine plugin directory,
Yeah.
and you have a plugin in the project plugin directory, and they have the same name, the project plugin version will be preferred. And so what I would tell those licensees, I'd be like, just copy the plugin to your project directory, and then you can just change it however
Yeah.
you want. Which is not a great. That's not extension.
Well, I mean, it's still a useful tip, though. Like,
it's a useful tip. Yeah. The
but-
other ask is for VFX. VFX has asked for to be able to attach particle systems to Soundscape
yeah.
spawns. And the answer is the same. Because at the fundamental behavior of a Soundscape color is to manage a pool of components. That's basically what it's doing. And it's got a bunch of update spawn behaviors and timers and stuff like that. But otherwise, you could swap out a particle system component instead, and it would work. The only thing is, and this is something that I've learned working with VFX, is that they would not want to operate a pool. VFX implementation of a color would just be one particle system component with an input for a spawn coordinate. So instead of spawning, because like colors spawn and manage audio components, instead of spawning an audio component in space, it would address its sort of managed particle system component and then just say spawn at this location. And so that way you have like a single system managing multiple particle lifetimes. That's sort of how Niagara works. Niagara is just more suited and more optimized for like a single system managing many different simultaneous particles. Much more like a granulator.
Sure.
Yeah.
So I guess then, since you brought it up, like, would you want to elaborate on how you would make Soundscape more extensible? Because I think
so I have some ideas. So one of the ideas would be to separate, like if you look at the color class, the data asset, you have all these categories of parameters. Like there's a set of parameters that just are responsible for modulating parameters. Right? There's like a space where it's like, what sound do we spawn, and
Hmm.
what sort of initial volume and pitch do we provide it? And you have parameters are like, what's the distance that you want to spawn? You know what? And then there's one that's like, there's a set of parameters that are like, what rotation do you want to give this? All this sort of stuff. And so there's, if you could logically break up the parameter sets into smaller chunks, and then you have a whole set of conditions, conditional spawns and
Hmm.
stuff like that. And so what I would do to make soundscape more extensible would be to create a sort of modular color system where you would have like a uh, instance subobject,
Hmm.
which in Unreal is really nice. The instance subobject is really handy because it gives you an instance of the object in the actual data, and so you can create a subclass or a superclass for the parent class for these subobject instance subobjects, and their class types will show up in like a nice convenient drop down menu,
Hmm.
and then when you select it, it'll basically populate the particular parameters that are specific to that class. And so I would separate all of those behaviors into a set of or a list. And so someone could maybe go in and say, "Well, I want to just manage, you know, some of the behavior is inferred through multiple parameters." So like for example, in Soundscape right
Mm.
now, if you just want to spawn one sound and just have it live forever, live the lifetime of the color, you just don't respawn, right? Like
Yeah.
you just don't tick that box. All that stuff that's sort of under a checkbox could be like a separate sub-object.
Yeah.
And you could just have an array of them,
Hmm.
uh, of different classes. So you'd be like, here's all the behavior spawning behaviors I want to use. Here's all the conditions I want to apply, that sort of thing.
Yeah.
And it's a little bit different approach to how the design would work. Under the hood, obviously, be different.
Yeah.
How those interact with each other be different, but fundamentally, it would allow you to define your own
That's where the
subclasses.
extensibility is.
That
You can
becomes the
then add
extensibility.
your
Yeah,
own behavior or
yeah,
set of data that you want to inject or like
yeah.
compose into your
Yeah,
color.
exactly.
Yeah.
One of the other big things is that I would love to change is the spatial data object. So that would be get down to creating an interface for how soundscape colors query into the spatial data, which I
Mm.
call color points. And so codifying an interface so that the other side of that interface could be
You can
anything.
swap it out for some
You
other
just swap it
system.
out. Yeah,
Yeah.
exactly. So I'm using a spatial hash of these sort of rigid grid densities,
Hmm.
or resolutions, I should say. But like, it'd be cool. Like, what if you could do an octree, or what if you could do some other spatial, a KD tree or something? Yeah,
Just
there's,
leaving the door open for anything new in the
yeah,
future too.
exactly.
So.
Yeah. So those are the different kinds of things that would be really great to. I have a big list of stuff that I would love to
Mhm.
do for Soundscape that's kind of along those lines. And the fun part of it is the idea that someone can go ahead and like make some weird,
Yeah.
cool new thing about it.
Yeah, for me, like designing systems, like I always try and think of like what parts of the system do I want to leave open ended for
Yeah.
people to go crazy with,
Yeah.
and then I build around that, and it's it's usually also constrained somewhat by the environment that the system is within, right? So
Yeah.
I've got constraints of just my environment, but then I'm also got constraints of what I'm trying to leave open ended, and
Yeah.
then everything else just kind of gets wrapped around that, so I can preserve those priorities, I
Yeah.
guess. Um, and I think yeah, that's what I enjoy about design is finding those challenges and making making ways for people to extend it.
Yeah. Absolutely. I totally agree. I think there is a sort of, you need to keep your head up. You need to keep aware of the context again that you're working within. Like for example, I was working on this I mentioned before, this interactive music system
Hmm.
as more general purpose, and I was like, I need to do arbitrary parameter evaluation
Yeah.
for state management, and I was like, okay, and I created this whole like class of objects that's like, here's a data blob, and here's a, this data container, and here's the different data implementations, and it's subclassable and all this sort of stuff. So you could create like your own evaluators. And made the system. It worked like I had it working like on its own, like I sort of prototype and blueprints, like the interactions and all this
Yeah.
sort of stuff. And I was like, but like state tree does it better. Like,
Yeah.
like
Yeah.
there's already something that handles this kind of situation. And like I even had like things that would modify, like I think they called modifiers, modify the
Mm.
container to objects. Like it was crazy. And so I was I felt like it was work that I should have reconsidered on the outset, and just
Yeah.
been like, "Oh, I could just incorporate some other general purpose system to handle this for me."
Like you said, you
And
just got to keep your wits
yeah,
about what's
exactly.
developing around you. And yeah, I've reinvented a few wheels in my day.
Yeah. Uh, working with Dolby Atmos, does it work well with soundscape, or is it not worth it for soundscapes? Is it's meant to be background layer? Well, so yeah, this is an interesting question. So first of all, soundscape doesn't handle spatialization. It spawns sounds in 3D space. Sounds themselves could be spatialized or not. Like for it could spawn a sound to your left, but if the sound's not spatialized, it will just sound unspatialized. And the Atmos implementation goes through a spatializer that's sort of the Dolby plugin, basically, and it converts. The Dolby plugin's really interesting. It has a upwards cap of n number of uh, uh, objects, basically. And so when you think about Atmos, there's usually two major parts of it. One is that you usually feed Atmos a surround bed, and that's sort of like objects that are stationary that represent virtual speakers, and then you feed them individual sounds through the spatializer plugin that they provide for Unreal. And what happens is that the plugin handles sound priorities for object. So, as an example, let's say you've got a bird tweeting in a tree, right?
I like the birds tonight.
The bird tweeting in the tree. This is going back to basics. We've got a bird tweeting in a tree. It's kind of elevated, right? What's going to happen so if you say, I want that bird to be spatialized by the Atmos system, right? So what's going to happen is bird's source audio is going to get sent to the spatializer, and the spatializer is going to be like, okay, how many sound sources are coming into the system, and then maybe it's a whole bunch of them, right? And it'll prioritize them. And then what's going to do is it's going to have some upwards cap, like maybe it's 16 or 32. I don't know, remember what it is. And it might be different by platform. I don't know. But it'll have some upwards cap. And all the sounds that fall below that list get mixed into the bed. So if the bird's tweeting, it's a low priority sound because it's just a background sound. But it's the only bird tweeting, or maybe it fits inside that, it's within the range, then it's going to be spatialized up there. If it doesn't fit with the range, then it's going to be mixed into the bed. And the bed may, or I don't know if the bed has as a height layer. It might have a height layer, but that's how that's how the Atmos thing works. And when you're talking about sound sources, whether they're background or important or trivial, that's about prioritization for the sound source. So a gunshot's going to be more important than a bird, probably, maybe.
For the bird, maybe. Yes,
For
I
the
might
bird.
be concerned.
so that's where that's so in other words, they have nothing to do with each other. Soundscape has nothing to do with Atmos. Atmos has nothing to do with Soundscape. But you can spawn an elevation. Soundscape allows you to spawn above you, below you, etc. And so sounds, when prioritized, spawned by Soundscape, will make the list of object audio and be one of the little crawling objects in their like virtual theater. And the ones that don't get mixed into the bed. So I hope that answers that question. I think this is a great example, actually, of two systems that just work, but they don't need to know about each other.
Yeah.
All the sort of connective glue is the spatializer plugin, which is part of the source render pathway. And that's just like the extending the audio engine. And the spatializer plugin is an interface available to plugins as an extension to the spatialization mechanisms that already exist in the audio engine itself. So that's a great example of a system that's extending the audio engine. And Soundscape is actually not an audio engine system. It's a gameplay system that manages audio components.
Mm-hmm.
So, yeah. Yeah. Thanks for asking. It's an interesting question. Oh, nice. Greetings. Is Buenos Aires is like is that Central Time? Is it west? Is it east of us? I forget. I always forget.
I think it's east or central.
Because I always forget that South America is like a little bit. Because part of me just wants to put it in like a big column in my brain. But I used to interact with folks on like the coast of Brazil, and they'd be like even more than far than the East Coast, and I'd always forget that.
We should just be West America, and they should be East America.
Yeah, that's right. Cool. Yeah, thanks for joining us. Awesome. Yeah.
It's a good discussion.
Yeah, it's been fun. It's been fun hanging out. I even got the hat on eventually. I went through all my Boylan's root beer. Boop.
Oh, it's 1 a.m.
Oh. 1 a.m.
Yeah, that's pretty big difference. More than I thought it was.
That's a huge difference, yeah.
Oh, I can see that. Yeah, makes sense.
Now I'm looking at a map. I gotta look at a map. You got me looking at maps. Scrolling out.
I think a globe would be a better illustration.
Yeah. Yeah, so not quite as east as Brazil, but pretty far, yeah. On the coastal area. Well, that's pretty cool.
So this is the last stream of the year, right?
This is the last. Yeah, so thanks for that's a good reminder. So it's just a Thursday thing, I don't know. It's just a Thursday thing. So the next 2 Thursdays are going to be holidays, and so I figure I'd give everyone a break. I will have some time off. I might do a non-tech audio chat live stream. I've been thinking I've been hankering to do another like Metasound jam,
Okay.
but there's no promises. There's no guarantees. This may be the last chat of the. See, this is sort of done on a whim. So I don't know. Maybe this could be the last one ever. But I like them, so I think they're going okay. So you never know. And I don't know when it's all going to be a little bit future. Maybe we come back on the 8th. Maybe not.
You'll have to find out.
Just say stay tuned. You know what you could do is you could subscribe and hit the notification bell to let.
I can't believe
I couldn't even get through. I couldn't get through it. I couldn't get through it.
You made it far enough.
Yeah, we haven't even talked about our non-sponsor.
Here we go.
The Perennial Tea Room.
I couldn't believe. I thought we were going to make it through. But, at least it's at the end. So
yeah, you've made it this far. You can make it a little bit farther by going to the perennialtearoom.com. Or sorry, it's just perennialtearoom.com and ordering Seattle's premier tea. Oh wait, ordering tea and tea accessories from Seattle's premier tea resource, the Perennial Tea Room, located near Pike's Market on Post Alley.
I'm not a native Seattleite, but it's Pike Place Market.
It's just Pike?
Yeah, it's not Pike's Place. You will get an earful from native Seattleites. And
well,
I'm just warning you. You've been here longer than me. You should know this.
I don't actually interact with native Seattleites.
I mean, that's very Seattle of you. So,
yeah, I don't know if they'll ship to Argentina either. But yeah, I love this tea. I would say, here's what I will say. If you're in the area, check them out. If you're not in the area, support your local tea shop. Like, tea is a special thing, and it's kind of insane. It's as insane a premise of like I'm gonna work in video games as it is to be like I'm gonna run a tea shop. So support your local tea shop.
Wars have been fought over tea, right?
Yeah, presumably. I don't know if wars have been fought over video games yet.
You don't know?
Wars have been fought over tea. I think they have.
Probably, or at least like conflicts.
Tea is one of the oldest beverages in human history. So who knows what people have done over tea. I like relaxing over tea and or just enjoying the tasty tea. So
all right.
Let's happy holidays, people. And maybe we'll see you around, right? Keep on tech audioing.
Have a tech audio year.
Have a year. Bye-bye.